In the grand game of data, numbers are like individual cricket balls. A single delivery can tell you speed, spin, line. But to understand the story of the match, to feel its ebb and its flow, you need to see the whole over, the entire spell, the full innings. A spreadsheet full of numbers is just a collection of deliveries. It's raw information, certainly, but it lacks context. It lacks narrative. Data visualization is the art of turning that raw data into a compelling story. It is the highlights package that shows you turning points, the crucial moments, the patterns that define the outcome. You see, our brains are wired for visuals. We are pattern seekers by nature. Presented with a table of 1,000 rows, our eyes glaze over. But show us a chart where a line soars upwards, and we immediately understand growth. Show us a bar that towers over others, and we instantly recognize dominance. This is the magic of visualization. It takes the abstract and makes it tangible. It allows us to spot trends, identify outliers, communicate complex insights with breathtaking clarity and speed. It's the difference between listening to a cricket match on the radio and watching it live in high definition. Both give you the facts, but only one truly lets you experience the game in all its glory. Think of it like this. A captain on the field gets constant streams of data. Batsmen's preferred scoring zones, bowlers' most effective length, wear and tear on the pitch. Instead of reading from a manual, they see it. They see the field placements, they see the batsman's stance, they see the bowler's run-up. They are visualizing the data in real time to make informed, strategic choices. In the modern era of data science, the answer, more often than not, is Python. This programming language has emerged as the undisputed champion, the all-rounder of the data world. It's not just a powerful tool for crunching numbers, it's a magnificent stadium for displaying them. Python offers a rich ecosystem of libraries, each a specialist player in its own right, designed to help you create stunning visuals, informative visuals, interactive visuals with remarkable ease. It's like having a full squad of world-class players at your disposal. Why Python, you might ask? Well, it's a combination of factors that make it a crowd favorite. First, it's incredibly versatile. You can use it for everything from gathering data, cleaning data, building complex machine learning models, visualizing results. This end-to-end capability means you don't have to keep switching tools. Second, it has a massive and active community. This is like having a passionate home crowd behind you. In the world of Python visualization, that foundation is Matplotlib. It is the Sachin Tendulkar of plotting libraries, venerable, powerful, and the benchmark against which all others are measured. It provides you with a tremendous amount of control over every single element of your plot, from the major axes to the tiniest tick marks. While it might seem a bit daunting at first, understanding Matplotlib is crucial, as many other tools, including Seaborn, are built directly upon it. Before we can start plotting, we need to make sure Matplotlib is in our kit bag. Installation is straightforward, managed by Python's package installer, pip. You simply open your command prompt or terminal and type a simple command. Pip install Matplotlib. Once installed, using it in your Python script or notebook begins with an import statement. By convention, we import the pipplot module from Matplotlib, which contains the functions for creating plots, and we give it a shorter, convenient alias, PLT. So, what we are about to embark on is a journey. It is a journey into making sense of the noise. We will learn how to take a seemingly chaotic jumble of numbers and arrange them into a beautiful, coherent picture. This is not just a technical skill, it is a form of powerful communication. It is about becoming a storyteller, where your characters are data points and your plot is the insight you uncover. It's about showing, not just telling. Because in data, as in life, a picture is truly worth 1,000 numbers, and seeing, as they say, is believing. Now, if data visualization is the art, then what is the canvas? What are the brushes and the paints? In the modern era of data science, the answer, more often than not, is Python. If Matplotlib is the meticulous craftsman who builds the stadium brick by brick, Seaborn is the master architect who designs beautiful modern facades with a few swift commands. With our canvas ready, let's start painting. The first strokes we'll learn are two of the most fundamental in all of data visualization. the line chart and the bar chart. The line chart is the master of showing trends over time. It's like watching a batsman's score accumulate over by over. The continuous line connects the dots, revealing the pace and momentum of the innings. Let's imagine some simple data. Suppose we have the number of runs scored in the first 5 overs of a T20 match. Overs =, 1, 2, 3, 4, 5. Runs =, 8, 15, 21, 29, 38. To visualize this with Matplotlib, we first set up our plot as before, fig ax =, plt.subplots. Then we use the ax.plot method. We simply pass our x values, which are the overs, and our y values, which are the runs to it. Ax.plot overs runs. This single line of code tells Matplotlib to draw a line connecting the points defined by our data. Next up is the bar chart, the undisputed champion of comparison. While a line chart connects continuous data, a bar chart is perfect for comparing quantities across different categories. Think of comparing the total runs scored by different players in a tournament or the number of wickets taken by different bowlers. Each player is a separate category, and the height of their bar represents their total runs. Let's create one. Suppose we have a few players and their scores. Players =, Kohli, Rohit, Surya. Scores =, 76, 45, 112. After setting up our fig, ax =, plt.subplots, we use the ax.bar method. Similar to the line plot, we pass our categories, which are the players, and their corresponding values, which are the scores. Ax.bar players' scores. Matplotlib will automatically create a bar for each player, with the height proportional to their score. When we call plt.show, we will see 3 bars standing side by side, making it immediately obvious that Surya had the highest score. A basic plot is like a raw talent. It has potential, but it needs polishing to become a true match winner. A chart without labels or a title is like a scorecard with no player names. It shows the numbers but tells you nothing about the context. This is where customization comes in. Matplotlib gives you an incredible arsenal of tools to add that professional finish to your visuals, making them not just informative, but also easy to interpret and visually appealing. We can add this crucial information using a few simple methods on our ax object. Ax set title, runs scored in the power play. Ax set x label, over number. Ax set y label, total runs scored. Just these 3 lines of code transform our ambiguous line into a clear, self-explanatory story about a team's scoring progress. It's like adding commentary to the visuals. It guides the viewer and ensures there is no room for misinterpretation. But we can go further. What if we want to compare the run progression of 2 different teams on the same chart? Plot Team 1, ax, plot overs, Team 1 _ runs, label Team 1, E. Plot Team 2, ax, plot overs, Team 2 _ runs, label Team 2, ax.legend. Now our single visual tells a comparative story. Finally, let's talk about style. Line colors, line styles, dashed or dotted, marker styles, other visual elements. Ax, plot overs, runs, color red, line style =, marker O. Plt style use, ggplot. This is like changing your team's jersey. It instantly gives your output a fresh, professional appearance. While Matplotlib is the powerful all-rounder, sometimes you need a specialist. Enter Seaborn. If Matplotlib is the meticulous craftsman who builds the stadium brick by brick, Seaborn is the master architect who designs beautiful modern facades with a few swift commands. Seaborn is a Python data visualization library built on top of Matplotlib. Its primary goal is to make more attractive and informative statistical graphics. It excels at handling complex data sets, especially those in pandas data frames, and creating sophisticated plots with very little code. The key difference lies in the level of abstraction. Matplotlib's primary API is very functional. Draw a line from this point to that point. Put a label here. Seaborn's API is more declarative and data-aware. Plot the distribution of this variable. Show the relationship between these 2 variables, broken down by this 3rd category. It understands your data's structure, especially when you use pandas data frames, and it makes intelligent choices about how to map the data onto the visual representation. Getting started with Seaborn is just as easy as with Matplotlib. You install it via pip install Seaborn. then import it with the alias SNs. Import Seaborn as SNs. Many people import both Matplotlib and Seaborn. Seaborn's plots are still drawn on Matplotlib's axes. Simply importing Seaborn can automatically apply improved default styles to all your Matplotlib plots, so why use it? The first reason is aesthetics. Seaborn's default color palettes, figure styles, and grid layouts are more visually appealing and easier to read than Matplotlib's defaults. The second, and more important reason, is statistical awareness. Seaborn has built-in functions for statistical plots. Distribution plots with kernel density estimates, regression plots that automatically fit and draw a linear model, and categorical plots that can compute and display confidence intervals. It simplifies moving from raw data to statistical insight, the true purpose of data analysis. Together, they form a formidable opening partnership, capable of tackling any data visualization challenge you throw at them. Now that the specialist is at the crease, let's see some of the beautiful shots it can play. Seaborn makes creating what are often considered advanced visualizations incredibly simple. Let's start with a histogram, a powerful way to understand the distribution of a single numerical variable. It groups numbers into ranges, bins. The height of the bar shows how many data points fall into that range. One-liner, SNs.histplot, data =df xarg. Pass your data frame and the column age. Instantly get a beautiful histogram, often with a smooth density curve overlaid. Next, the box plot, a masterpiece of statistical summary. A box plot shows the median. It shows the interquartile range, middle 50%. It shows potential outliers, great for comparing distributions across categories. Example, compare player ages across teams. One-liner, SNs.boxplot, data =df x team, yarj. Seaborn groups data by team. It draws a separate box for each team's age distribution. Now the scatterplot. Investigate relationships between two numerical variables. Seaborn's SNS.scatterplot goes further. Plot x versus y. Use color, hue, to encode another variable. Use size to encode yet another variable. Example, sense.scatterplot. Data =df. X =balls underscore faced. Y runs underscore scored. Hue batting underscore position. Each point is a player's innings. Color indicates opener, middle order batsman, tail ender. Reveals deeper patterns. Finally, sens.pairplot, the ultimate power play. One command, sns.pairplot.df, creates a grid of pairwise plots. For each pair of numerical variables, a scatter plot. On the diagonal, histograms of each variable. A quick, high-level overview to spot interesting relationships. Like a full performance summary for every player in one elegant report. Theory is one thing, but a player's true quality is revealed in a high-stakes match. Let's apply our new skills to a real-world dataset, the famous Titanic passenger list. This dataset contains information about the passengers, age, gender, ticket class, whether they survived. Our goal is to use visualization to understand the factors that influence survival. First, we load the data. Titanic =sense.load data set, Titanic. This loads the data into a pandas data frame. Our first question is simple. What was the overall survival rate? A bar chart is perfect for this. We can use Seaborn's countplot function, which counts occurrences in a category. SNs.countplot, data =Titanic, x years survived. 1 bar for those who did not survive, 0. 1 bar for those who did, 1. We can immediately see that tragically, more people perished than survived. Now let's dig deeper. Did gender play a role? This is a classic comparison across categories problem. SNs.countplot, data =Titanic, Ts survived, Huisex. Seaborn produces the plot. Each bar is split by color to show males and females. A vast majority of the survivors were female. A huge proportion of the deceased were male. What about ticket class? Did wealth make a difference? A bar chart can answer this. Let's look at the survival rate within each class. SNs.barplot, data =Titanic, XR class, Wyod survived. Seaborn calculates the mean of survived. 1 = survived, 0 = not, for each class. First class had a much higher chance of survival. Second class fared worse than first but better than third. Third class had the lowest survival probability. This single chart tells a powerful story about social stratification in a moment of crisis. So, we've seen both players in action. Matplotlib, the reliable veteran, and Seaborn, the stylish specialist. Which one should you pick for your team? The answer, like in cricket, is that it depends on the situation. You don't have to choose one over the other. The best teams have a balanced squad. The real power comes from knowing when to use each. Matplotlib is your go-to for fine-grained control. When you need to create a highly specific or custom or non-standard plot, Matplotlib handles that. Seaborn, on the other hand, is your choice for speed, beauty, and statistical insight. For exploratory data analysis, you can quickly generate beautiful statistical plots. A plot that might take 10 lines of careful Matplotlib code can often be generated in a single, expressive line of Seaborn. Remember, you can always use Matplotlib functions to tweak a Seaborn plot after it's been created. For most common data science tasks, starting with Seaborn is often the most efficient path. Here are a few key tips for your visualization journey. First, always label your axes and give your plot a title. A plot without labels is meaningless. Second, choose the right plot for your data and your question. Use line charts for trends over time. Use bar charts for comparing categories. Use scatter plots for relationships between numerical variables. Use histograms for distributions. Third, don't clutter your plot. Too much information can be as bad as too little. Keep it clean, simple, and focused on the main story you want to tell. Use color and size purposefully to highlight information, not just for decoration. Finally, the most important tip is to practice. Data visualization is a skill, and like batting or bowling, it improves with practice. Grab a dataset that interests you, ask questions, and try to answer them with visuals. Experiment with different plot types and customization options. Don't be afraid to make mistakes. Every plot you create, even a messy one, teaches you something. The goal is to become a fluent storyteller with data, and that fluency comes from a continuous process of exploration and creation. So keep your tools ready and keep looking for the next story hiding in the numbers. It's a wonderful game, this. Enjoy it. As you advance, explore Seaborn's statistical plots, distribution plots with kernel density estimates, regression plots that automatically fit and draw a linear model, and categorical plots that can compute and display confidence intervals. You can often create a complex, multi-layered plot in one line of Seaborn code that would have required many lines of careful Matplotlib setup. It integrates seamlessly with Pandas data frames, making intelligent choices about how to map the data onto the visual representation. Remember, you can always use Matplotlib functions to tweak a Seaborn plot after it's been created, giving you the best of both worlds. In the world of business, science, technology, data visualization gives us that same captain's eye view, empowering us to make smarter, faster, and more impactful decisions that can change the course of our own game. We are pattern seekers by nature. Show us a chart where a line soars upwards, and we immediately understand growth. Show us a bar that towers over others, and we instantly recognize dominance. This is the magic of visualization. It takes the abstract and makes it tangible. It allows us to spot trends, identify outliers, communicate complex insights with breathtaking clarity and speed. It's about becoming a storyteller, where your characters are data points and your plot is the insight you uncover. It's about showing, not just telling. Matplotlib is your go-to for fine-grained control. When you need to create a highly specific or custom or non-standard plot, and if you want to control every single pixel, Matplotlib gives you that flexibility. Seaborn is your choice for speed, beauty, and statistical insight. For exploratory data analysis, you can quickly generate beautiful statistical plots with less code and intelligent defaults. Understanding Matplotlib is non-negotiable. It is the foundation, and mastering the basics here will pay dividends throughout your data science journey. The journey of mastery is continuous. Keep experimenting with different plot types and customization options, always looking for new ways to reveal insights in your data. This is not just a technical skill, it is a form of powerful communication. Because in data, as in life, a picture is truly worth 1,000 numbers, and seeing, as they say, is believing. What we have embarked on is a journey into making sense of the noise. We have learned how to take a seemingly chaotic jumble of numbers and arrange them into a beautiful, coherent picture. You now have the tools to transform raw data into compelling stories, to spot trends and patterns that others might miss, to communicate insights with clarity and impact. Remember, like any skill worth mastering, data visualization improves with practice. Don't be afraid to experiment, to make mistakes, to iterate and improve. Every data set has stories waiting to be discovered. Every chart you create brings you closer to fluency, this powerful language of visual communication. Your toolkit is now built with both Matplotlib for data entry and Seaborn for elegant statistical graphics. Use them wisely, use them often. What if data science insights your visualizations, your unique perspective on the patterns hidden in numbers? Go forth and visualize. Transform data into understanding, numbers into narratives, complexity into clarity. The game of data visualization is yours to play. Make it count.